Today's topic is indirect redox reactions. We are in the chapter redox reactions, and today's topic is indirect redox reactions. You know that we have already seen direct redox reaction. What happens in a direct redox reaction? The oxidation and reduction takes place in the same this beaker. For example, if we put zinc rod in a copper sulfate solution, what happens? Zinc gets dissolved to form Zn2 positive ions, and these electrons lost by zinc are picked by copper. Since copper sulfate solution contains copper 2 positive and sulfate 2 negative, these electrons are picked by copper positive to become copper. It becomes copper, and that is deposited below on the bottom of the beaker, and this rod loses weight because this zinc goes into solution. This is direct redox reaction. And there is an energy change. What happens? This beaker gets warm. It means that the energy is released in the form of heat energy. But we can do this in two different beakers. We take two different beakers. In one, oxidation takes place, and in another, reduction takes place. This is called oxidation half cell, and this is called a reduction half cell. In oxidation half cell, electrons are released. These are carried by an external circuit, by an external wire, which is connected to the this reduction half cell. Here we have two rods. We put zinc rod in 1 molar solution of zinc sulfate, and here we put copper rod in the copper sulfate solution, 1 molar copper sulfate solution. The two solutions are also joined by a we call this salt bridge. This is a U-shaped tube in which we put a paste of potassium chloride, potassium nitrate, or ammonium nitrate. Potassium chloride, potassium nitrate, or ammonium nitrate. Why these? Because these don't have any reaction. These are neutral to both these solutions. If they react with this, then the whole dynamic of the reaction will change. Now, what happens when electrons are released here? They move through this. Here we have a key. When we connect this key, they move to this, and this movement of electrons is basically electric current, and this current is used to power our torches, batteries, etc. Okay, so let us see how this works. What happens here? When zinc is placed in this, zinc loses. This is solid zinc. It loses 2 electrons to form Zn2 positive plus 2 electrons. Okay, so when it loses these electrons, these Zn positive go into the solution. It means the concentration of zinc in the solution increases. Okay, this rod loses weight. It becomes thinner and thinner and thinner. Electrons move here. Here we know, here we have copper positive, 2 positive ions. These electrons, there is abundance of electrons available here. They are picked by these copper, and copper gets deposited on. This changes into copper, changes into it adds 2 electrons to form copper solid, and that is gets deposited on this, and we call these 2 rods, we call electrodes. Okay, so copper gets deposited, the weight of this electrode increases, the weight of this electrode decreases. Okay, so this movement of this electrons is electric current, which we use for different purposes to power our different these devices. This arrangement, where we have 2 beakers, we carry oxidation and reduction reactions in separate beaker. This is called an electrochemical cell. So this is an electrochemical cell. So what is an electrochemical cell? Electrochemical cell, it is a device which converts chemical energy into electrical energy with the help of a redox reaction. What mean? It is a device. It is a device which converts chemical energy into electric energy. This is also called a galvanic cell or voltaic cell. Galvanic cell or voltaic cell. Galvanic cell or voltaic cell. Why galvanic cell and voltaic cell? Because these were first simultaneously made or invented by Louis Galvani, Louis Galvani, and Alexandro Volta. So they simultaneously invented this cell, and therefore this is called a galvanic cell, or galvanic cell or voltaic cell, in the name of two scientists who separately and independently invented this cell. Okay, then we have solved this. We will discuss this in another video.